2 of Algebra 1. You guys are doing excellent so far. And it is Tuesday, March 25th. So yesterday we had a very short lesson. Did about 20 minutes of instruction after everything was said and done. And we talked about solving equations. We did 1-step and 2-step equations. So for your do now, I've given you 4 different equations here that are either 1 or 2-step. And then the fifth one is a little challenge problem that some of you were able to figure out, but this is a multi-step equation. That's actually more than 2 steps. So let's just start by looking at number 1. And I would like to know, what are some of the values that you guys got for x? Just shout some numbers out at me.
10.
You got 10? Did anyone get something different than 10? Everyone got 10? All right. Well, who wants to tell me how to do it? Go ahead, tell me. What'd you do first?
I subtracted 10 from and under 40.
Perfect. So 10 on both sides.
10s cancel.
Mm-hmm.
And I brought down 3x equals 30.
3x equals 30. And give me 1 second. I'm going to pause. All right. So now we have 3x equals 30. What did you do from there?
And I took 3 and divided it from each side.
Perfect. Divide by 3.
And 3's cancel.
Mm-hmm.
So x equals 10.
X equals 10. Perfect. You guys are right. Amazing. Okay, let's look at number 2. What values of x did you guys get on number 2?
50.
50? Did anyone get something different than 50? That is wonderful. It is 50. How do we get 50?
Multiply 2 on each side.
Good. So I have x divided by 2. I want to multiply by 2 on both sides. And what happens over here?
So the 2's cancel on the left.
Perfect.
And then 2 times 25 is 50.
Perfect. I'll bring down my x. 25 times 2 is 50. So x equals 50. Awesome. Wonderful. Okay, good. Let's look at number 3.
7.
You got x equals 7. Did anyone get a different answer than x equals 7? Let's see. How do we solve number 3? Rhonda, tell me.
We divide 6 on each side.
Good. Divide by 6.
Cancel the 6.
Mm-hmm.
And then 6 divided by 42. Well, 42 divided by 6 is 7.
Perfect.
And then equals x.
Perfect. Let's bring the rest down. Equals x. And 7 equals x. That's the same thing as x equals 7. Beautiful. That is our answer. Okay. Awesome. Let's look at number 4. What kind of answers did we get for 4?
20.
X equals 20. Did anyone get a different number? Okay, well, let's see who would like to walk me through this one. Okay, go ahead, Jessica. What'd you do?
Number 4. Are going to add 3 to each side.
Perfect. I've got a -3. So to get rid of that, we're doing the opposite sign here. Plus 3 on both sides.
Your 3's cancel.
Good. My 3's
Bring your x
cancel.
divided by 4. X over 4 equals 5.
5. Good.
And then you're going to multiply by 4 on each side.
Perfect. So now we have x divided by 4, so we multiply by 4 on both sides.
Your 4's cancel.
Beautiful.
And your x equals 20.
X equals 5 times 4 is 20. Amazing. Now, is anybody confused about why I added 3? Because this is a little bit tricky for some, considering that we have -3 plus items.
Because if you do -3 minus -3, you get
Yes, if I decided to do -3 on both sides, what would happen is my threes wouldn't cancel. -3 minus 3 is -6. So we would have a different problem here. To get rid of a negative, we add. Do the opposite. Beautiful. Okay, any questions about 1 through 4 before we go to 5? Right. Number 5, this is our challenge. Who
Four.
feels good about it? Titania, you want to guide me?
Yep.
How do you do it?
I added 3
Okay,
and I added the 3 to the 1.
perfect. So we added 3 to both sides.
And the 3's cross out.
Mhm.
So 2x minus 4 equals 4.
Perfect. What'd you do next?
Now I subtracted that 4.
Subtracted.
Oh, yeah, the added.
Ah,
I did
yeah,
it backwards.
You got it. You got it.
Yeah,
Just add
add 4 to
now.
both sides.
Perfect.
The 4's cancel. So 2x equals 8.
2x equals 8.
Now I divide it.
Yeah.
2 from each side. The 2's cancel. X equals 4.
X equals 4. Awesome. So, what was different about this problem compared to the others?
Added an extra step.
We added an extra step there. Now, this wasn't too much different. It was really just doing one more of the same step, getting rid of addition and subtraction. So, this problem is a great example of we get rid of a subtraction, or I guess this is technically -3 plus 2x. Same thing as -3. We got rid of that -3. And then we don't move on to multiplication and division yet, because we still have more addition and subtraction. So this is a great problem that shows we continue doing addition and subtraction until there's none left. Then we switch to the next operation. So that was our do now. You guys did amazing. How do you guys feel? Feel good? Good. Yay. Awesome. Okay. So moving on, let's get some notes out. I do want to mention again, if any of you need a notebook, things to write with, paper, colors, markers, all of those things are up at the front of the room. Also, if you don't like writing on the rough paper, we have clipboards up there. Feel free to take whatever you like. That is up there for you. Oh, let's go ahead and title this. This is Algebra 1. And we are in Unit 1. And as I'm writing this title, feel free to get yourself situated and get whatever you need. I'll make sure everyone's ready before I start giving you stuff. So we take one of our notes.
I have a question.
Yes.
I'm leaving at 2, remember?
Yes.
Are we doing for the next period?
Yeah. We will have a little bit next period. So anything that you miss, it will all be recorded and put on Google Classroom. Hopefully it shouldn't be much that you miss because.
You know, I usually do my math.
Right. I'm not worried about you. You're reliable. All right. So this is our day 2 notes. It's just not wanting to focus. Okay. So, is everybody ready? Everybody have notes out? You guys good over here? Okay, good. Okay, so yesterday we talked about how to solve a one-step equation and how to solve a two-step equation. Now we've just introduced a multi-step equation. So, to sort of sum up what's happening here, I'm going to write out just a few steps. So, when solving an equation, all right, solving an equation. This is just a quick little reminder as we move through these problems. Our first step is always, unless we have an exception, which I will talk with you about today, Your first step is typically gonna be to get rid of any addition and subtraction. So I'm gonna write plus and minus. Then your second step is usually to get rid of multiplication and division. So you are gonna do step one over and over and over until there's no more step one left to do. Yes,
We already have these notes, we'll have to rewrite
that's
them.
okay. You don't have to. If this is something, like if I'm ever teaching you something and you already know it, don't feel like you have to write it again unless you feel like it helps you.
Okay.
A lot of this in the first week will be familiar. For my friends that just got out of pre-algebra, you'll have seen a lot of this. So let's look at a few multi-step equations. And I will write that as well. Multi-step equation.
You always wanna go left and right when you're doing the equation.
That is a great question. You always want to go left to right. I don't want to say always because it might depend on
The
the
way it's written.
equation itself. Like in number 5, with our -3 and our -4, we did go left to right. But if you would have done the 4 first, you would have still gotten the same answer. So you could have done it in either order. You don't have to do left to right when we're solving. Now, if we're not trying to solve for a variable, you do want to do left to right whenever we're using our order of operations. But we actually won't be using too much of that right now. So for now, I'm going to say no, you don't have to go left to right. But if I discover something that tells me otherwise, I will let you know.
Okay.
Okay, so let's say I have an equation such as, let's do 5 plus x divided by 3 minus 2 equals 12. When we have an equation where there are more than 2 steps, we actually have more than one option for the first step that we want to take. So I have 5 plus x divided by 3 minus 2. So what are some of the things that we could do first?
The 5 or the
Yes.
2.
The 5
either
or
one,
minus
either order.
2. Either or. You can do either one. You'll get the same answer. Okay? So how about we start with the 5?
You're -5 from 5 and 12.
Good. We have a positive 5, so we'll subtract 5.
5's canceled.
5s will cancel. And what do I do next?
Bring
7.
the problem
Oh,
down.
yeah.
Yeah.
X over 3.
Okay. All right. So we got rid of our 5. Now, whenever we go to the next step, we want to bring everything down with us to that next step so we don't lose anything. We have x divided by 3.
-2.
Good. Minus 2
Equals 7.
7. 12 minus 5. Perfect. So now we're here. X over 3 minus 2 is 7.
Then you add the 2.
Good. So now we add 2. We're still getting rid of addition and subtraction. So 2.
2's cancel.
2's cancel.
X over 3
Perfect. X over 3 gets brought down.
equals 9.
Equals 7 plus 2 is 9.
Now you divide 3 from the 9 and 3 from the 7.
You multiply 3.
Oh, multiply
Oh.
half backwards.
You know what's funny is we never get it wrong whenever it's something like 3x. Everybody always divides. That one we don't get mixed up. But even when I'm making my answer keys, for some reason, when I see a fraction, it's like you want to divide again. Why? I don't know. It's some weird phenomenon where we suddenly forget what to do here. But Brian, you are correct. We are actually dividing it to start with, so we need to multiply
Yeah.
to get rid of the 3. Perfect. So we are going to multiply by 3 on both sides.
X equals 18.
Yes, my 3's cancel, so x equals 9 times 3 is
27.
27. Good. Good, good, good. Awesome. So with a multi-step equation, it's not too much more. You're just adding another little step in there. And of course, we can get more and more complicated. But does this make sense to everyone that we cannot move on to division or multiplication until we get rid of all the addition and subtraction? We feel good about it? Okay. Well, now we want to move on and talk about, I'm just going to touch on this real quick because it's something we'll see lots. And this might even feel a little off topic. But what happens when I have, and I actually am going to do this on a sticky note, so it's to the side. What happens when I have, for example, something like this, 2 times 3x? Do we know that when you have a number or a term written in parentheses besides another number, are we all comfortable with this is multiplication?
Yeah.
Right? Great. So what is 2 times 3x?
6x.
6x. Great. You just multiply the numbers and carry that variable with you. So 2 times 3x is 6x. Now, what if we had something more like this? 2 times 3x plus 5. What would we do in this scenario? Do what's in parentheses first? Typically, yes. But in the parentheses, I have 3x plus 5. Can I add those together?
No.
Distribution.
You gotta distribute.
Distribution is what this is called. We're going to distribute. And this is our little trick around not being able to combine these. So does anyone know why we cannot do 3x plus 5?
Because you have to get rid of the x in order to do anything.
These are not like terms. Like terms means that they have the same variable attached to the number. So there is an x on my 3, there's not an x on my 5. So I cannot add and subtract them. Now, like terms has nothing to do with multiplication. You can multiply unlike terms, and that's fine. But adding and subtracting, we cannot. So to get around that, we're still going to multiply, but we're going to do both. 2 times 3x is 6x. And then I'll bring down my plus sign. 2 times 5 is 10.
Okay.
And that's it. That's your answer. So just a quick review on what distribution is. If we ever see a number or a term or some value outside of that parentheses, we're multiplying by everything inside the parentheses separately. Yes.
So you don't go any further? You said 6x.
That's the
10 is
answer.
the
Nope,
answer?
you can't go further here because these are not like terms. You cannot combine them. And it's not an equation this time. We're not solving for x here.
Okay,
Now, if I had like equals something, then we could keep going and solve it.
okay.
So that is distribution. I'm going to write that word up here in case it's new to anyone. Distribution. That's what this is. Distribution. You're multiplying.
Now, when you're doing that, you want to make sure if you have a negative sign on there that you follow the rules.
Oh, yes, Brian. Thank you for mentioning it. Let's bring some attention to that as well. So here's what I'm going to do. I'm going to give you another problem, another equation that we will do together, but I'm going to stick a negative in there on our distribution. So what if I gave you -3 and then in parentheses 4x plus 2 equals, let's see, make sure I give you a number that works. Let's go with, I hope this works. Go with 24. Okay. So this is a problem where there is an exception to the rule. Normally, we want to get rid of addition and subtraction first, but our addition, the +2, is stuck inside of parentheses. So anytime you have a value that is in parentheses like this, we cannot use it until we get rid of the parentheses. And we do that by using distribution. We're going to multiply by everything and get rid of it. Then we can start moving things around. So if I know I'm going to be using distribution here, what is my first step?
-3
Times 4.
Yeah. Negative 3 times 4x. What's that going to give me?
Negative 12x.
Good. Negative 12x. And what do I do next?
You distribute
Negative
plus
6.
sign.
Yes, it will be -6. You're going to distribute that -3 times +2. A negative and a positive give us a negative. So 3 times 2 is 6. It's negative. Negative 12x minus 6.
Equals 4. And then you add the
Yes.
equal 24.
Perfect. All we do next is bring everything the rest from, my goodness, my words. All we do next is bring down everything from the original equation so we can continue solving. So I will just write equals 24. Now I have a problem that I know how to solve. What should I do here?
You take and add the 6 to the 24.
Yes. So now we add 6 to both sides. And of course, I gave you numbers where you're going to get a decimal, so I apologize. So my 6's cancel, and what happens next?
Negative 12x equals 6. So we're going to
Equals
30.
30. Good. Now, we have negative 12x equals 30. What is my last step?
Divide.
Divide. What do I divide by?
Negative 12.
Good. Negative 12. This is another part where a lot of us make mistakes is we'll just divide by 12 and forget the negative. That will affect your answer. So if I have positive 30 divided by negative 12, what is the sign of my answer going to be?
Negative.
Negative. A positive divided by a negative will give us.
2.5.
So 30 divided by negative 12, you said it's 2.5?
Yeah.
Okay. Now, if you didn't know how to do that, I'll show you on a calculator that you guys have at your table, just in case. If you want to type a negative number in, you can do 30 divided by, the negative sign is right here at the bottom, right next to the equal sign. So I hit negative 12. And we will get, enter, negative 2.5. Perfect. So x equals negative 2.5.
2.5.
Yes, 2.5. Beautiful. Awesome, awesome. Okay, any questions on this problem here? That is beautiful. Amazing, amazing. All right, guys. I would like to give you a few to try on your own. But before I do that, I actually want to show you one more thing that you might see. And before I show you that one more thing, does anyone need to see this work still? Anyone still right? I'm going to go ahead to the next page. And I'm going to start a new one. I'm writing a little too big. And it's still Algebra 1. Now we're on page 2. Page 2 notes continued. So, We just looked at a problem where we have some distribution. But now, what if we have a problem like this? What if I gave you 2x minus 2? Okay. First glance, when we're looking at this problem, what might you think the first step to take would be?
Get rid of the fraction.
Ooh, get rid of the fraction. Okay. So normally, the first step is to get rid of addition and subtraction, right? Now, the only exceptions are when that addition and subtraction is in parentheses or when it's stuck in a fraction. So those are your two times that we have to do something different. When it's in parentheses or when it's in a fraction. This is on top of a fraction here. Now, a fraction is just a division problem. It's just 2x minus 2 divided by 3. How do we get rid of division? We multiply. So, how can I get rid of divided by 3 here? Multiply by 3. I'm going to multiply times 3 on both sides. And what happens over here?
You bring the rest of your problems down.
Yes, we're going to bring everything down. We got rid of the 3. So we're left with 2x minus 2 equals 2 times 3 is 6. Good. And now we have a problem that looks a little more manageable. Okay. What will we do next?
And
Add 2. Okay. My 2's cancel. What gets brought down now?
2x equals 8.
2x equals 8. Beautiful. And last step?
Multiply.
Perfect. So we have multiplication, and so we will do division, right? And 8 divided by 2 is 4. So we'll get x equals 4. That is our answer. Okay. How many steps was that? 1, 2,
3.
It might have just been 3. Yeah, we multiplied by 3, we added 2, we divided by 2. That's 3 steps. So we're only up to 3 steps. You would not believe how many steps can be added to these. It's wild. I won't go too much further with that though. Okay. Does this make sense to everybody? Good deal.
So we with the fractions.
Yes. So I am going to give you just a few to try on your own. I'll set a little timer. And then if we are all doing great with them, we're going to move forward today. So let me write some out. Try on your own. And can I move this up, or does anyone still need this work? Move it unless anyone tells me differently. Okay. Pause this real quick. Okay, I know I just said it, but I'm going to repeat it for the video. The worksheet I gave you has things I didn't teach you. So, let me teach you very quickly. If you ever have a problem such as on this worksheet, number 1, I'm going to write it out and show you what to do. If you already know how to do this, great.
Equations with variables on both sides.
This one actually will not have variables on both sides, but you will have 2 variables on one side, and we have to do something with those.
Okay.
So number 1 is 6a plus 5a equals -11. Who remembers, what is this called, these types of terms that have the same variable?
Like terms.
Like terms. if you have like terms, what can we do with them?
You can add
Combine.
them together.
You
or
can
subtract them.
combine them, you can add or subtract them. So what will I do to combine these?
Subtract.
Subtract?
You add them.
Oh,
If we are doing on different sides, you
Oh,
would subtract,
okay.
yes. But if they're on the same side of the equation, we just add them together. So 6a plus 5a is what?
11.
11a. So you'll get 11a
equals
negative 11.
No, excuse me.
And then you would solve the rest from there,
It'll
which
be
you would do what here?
Divide.
Divide by 11. And that's going to leave you with a equals negative 11 divided by 11 is
-1.
negative 1. Good. Good, good, good. So anytime you have a problem where you have the same variable written twice, if they're both positive numbers, you're just adding them. If you have a negative number there, that means you're subtracting it, okay? So does this make sense, or would you like to go through maybe another?
Find another one, do it, just do them all.
Okay, you guys got it?
That's
If
pretty
anyone
much-
wants more, just let me know. I'll pause this recording and let you guys do it. And for the people that are working at home, I'm just gonna show a quick shot of these problems in case anybody.
Why would
Yeah,
you?
there.
No,
There you go.
that don't sound right. No, I'm talking about my sister.
So we're back. Our timer is over. And let's talk about some of the answers for numbers 1 through 6. I believe I can fit all of those on the screen. But I can probably get all the way through 8. Here are the answers we should have gotten. For number 1, a equals negative 1. We
Yep.
did that one together. For number 2, n equals negative 2. For number 3, x equals 2. For number 4, n equals 0. For number 5, r equals 1. Number 6, r equals 2. Number 7, no solution. Now this one I will work out for you just to show you a little more what gave us no solution. And then number 8, we got p equals negative 12. Out of the first 8, are there any that you guys would like me to go through slowly with you? Number 8. Okay, let's look at number 8 then. All right, I'm going to move this to the side. I'm going to write down number 8 on my paper. Number 8 is negative 10p. Negative 10p.
Plus 9p
Thank you. Plus 9p
equals
equals
12.
12. Okay.
And that's -1.
Yeah, so let's see. We have negative 10 plus 9, both p. So you are correct. We're going to get negative 1p
Equals 12.
equals 12. So we just combined like terms here.
Now you divide the 1 into 12.
Yeah, so now we need to get p by itself. So we divide by negative 1.
Yeah.
And any number divided by negative 1, the number doesn't change, but the sign does. We'll get p equals negative 12.
Yep.
That's how we got there.
You do 6 as well.
Yes, absolutely. Okay, did that help, Milena? Yeah. Perfect. Okay, let's look at number 6. Number 6, we have r plus 11 plus 8r
Yeah.
equals 29. Okay, so what should I do first?
Subtract
Let's
11.
combine our like terms. Or I heard somebody say subtract. Did you say subtract 11?
Yeah, because
I-
ours
You
by
can do that first.
yeah, because ours by itself is so there's no like
Yes.
turn in it.
You actually can get rid of 11 first.
That's
You
what I,
can.
that's how I
Either
did
way
it.
works. So both ways will give you the same answer. You could even do both steps at the same time. You could say, well, 8R plus R is what? 9R.
Oh, that's right.
So I could just go ahead and
Yeah, 'cause
say,
that's what was confusing me. I was like, wait a minute.
there's my 9R.
Because I forgot ours
And
always
then let's
one.
subtract 11 from both sides. Okay? So I'm going to cross these off so I don't accidentally bring them down. My 11s, what happens?
Cancel.
They
Yeah.
cancel. And then what gets brought down?
R, 9R.
9R. So we're doing 2 steps at once. You don't have to do 2 at once. If that feels complicated, feel free to do it separately. So now I have 9R equals 29 minus 11 is 18. And what do I do next?
Divide.
Divide by 9. And we will get R equals 2.
That was right. I have no idea how I got there.
There you go. Hey, that's all right. Good stuff, guys. Good
Yeah,
stuff.
that's man.
Okay. Hopefully that helps a little bit. Are there any other problems, number 1 through 8, that we'd like to go through? I'll show you 7 if anyone's interested. Anyone interested in 7?
No.
No. I'm gonna show you anyway. Okay, number 7. I'm gonna write that out over here. We had negative 10 equals
Negative 14V plus 14V.
good. Negative 14v plus 14v. So let's
Add
see.
14s.
Yeah, negative 14 plus 14 is what?
0.
0. So I could write 0v, but would there be any point to that?
No.
No, because what this means is that there are no v's. So we don't need to write it. It's just 0. And then we'll bring everything down. So I have negative 10 equals 0. Can I do anything else?
No.
No. Is this true?
Yes.
Negative 10 is equal to 0?
No.
No, it's not true. So if you get something like this where I cannot go any further, and this is not true, we cross it out. We say no solution. That means it doesn't matter what number I plug into this equation for v, I won't get an answer that makes sense. This can never be equal to negative 10, ever. No solution. That's the answer. I'm going to show you the rest of the answers on that page. But before I do, does anyone need to see any of these before I cover them? Okay. All right. Number 9, m equals 2. Number 10, a equals negative 3. Number 11, x equals 4. Number 12, n equals negative 2. Okay, any questions about 9 through 12? Hey, did anyone make it to the backside? All right, let's look at a couple of them.
I ain't making it to 9.
That's all right. Don't even worry about it. If you only made it to like 3 or 4, that's okay. It's not a speed race.
Yeah, I made it to 9.
Okay, if you made it to the backside, here are some of those answers. Number 13, we should have gotten x equals 2. And you're more than welcome to write these answers down as you go so that now you have practice problems later to check yourself on. Number 14 is m equals negative 1. 15, x equals 1. 16, n equals 10. 17, v equals 2. 18, v equals 10. $19, b equals negative 1. 20, n equals 0.
We need a Work on those two, how they get 0.
Oh, on number 20.
And 21.
Okay, 20 and 21 are both 0. Yes, we can work those out together for sure. Let's see. 22, x equals -1. Ooh, we got some tricky ones back here. We've got variables on both sides of our equation on the back side, which is what we're about to do next. Okay, for the rest of these, if you don't know how to do them, that's okay. I didn't teach you yet. So amazing if you got it. Now, if you were in algebra or pre-algebra last term, I taught this briefly, but not in depth. We're going to talk about it more here. But for now, that is the answers to this worksheet. If anybody wants to see a copy of this answer key, you can always ask for it. I have it up here. Now, on the rest of the worksheet, other than these numbers 1 through 6, now we have, you said 20 and 21 we might want to look at. Are there any others? Let's start with 20 and 21, and then we'll ask if there's others. So I'm going to move to the next page, and we're going to talk about what's going on that backside. We have equations where there are variables on both sides of the equal sign. Okay, so we're going to start one more page of notes. And after I work this problem out for you, I will give you a break, okay? Because we are almost to 2 o'clock
Yeah, I'm
here.
about to leave too. So.
Yes, and that's okay. And I'll make sure to get you a copy of the Excel ticket and all of that. It'll only be one problem today. Day 2 notes continue. Page 3. So, on that worksheet, if you would like, we're going to start by looking at number 20. This one is a little complicated. So, number 20, we have -5n minus 8 times 1 plus 7n equals -8.
Oh, excuse me.
Okay, this one is interesting. What do you think we need to do first?
Distribution.
We are going to do distribution first. We need to get rid of the parentheses. So what is being distributed?
8 and the 1 and then plus the 7 in.
Yes, so we are using 8, but more specifically, since
-8.
it's -8, yes, it's -8. Anytime that we are distributing, we want to make sure we include the sign, which is always going to be to the left of the number. So let's work this out. -8 times 1 is
8.
not 8.
-8.
Oh,
-8.
-8. Good. -8 times +1. A negative times a positive gives us a negative. So we're getting -8. Now, -8 times +7n.
-56n.
-56n. Good. So I've done my distribution. What do I need to do next?
bring everything else down.
Bring everything else down. Now, I'm going to bring my equal sign down. On the other side of the equal sign, all I have is -8. Do I have everything over here?
Nope.
No, I'm missing this, my -5n. Okay, this is like a bajillion step equation. So, we've done the
Yeah.
distribution. That was step 1. Now, what's going on? What do I need
You
to do?
want to add your like
Combine
terms.
Let's combine our like terms. I'm going to change colors at each step. So what are my like terms?
5n and
Negative.
-5n and -56n.
We have -5n. I'll box that in. And -56n. So, -5 and -56, what happens when we put them
Yeah.
together?
Positive 51, 61.
Not positive. If it
Negative.
was multiplication,
Okay,
it would
hold
turn positive. But whenever you have a negative value and you add another negative value, it just becomes an even bigger negative.
Then 61.
Negative 61.
Yeah, negative 61.
Yeah. Good. So
Ooh,
we
61 something.
are gonna get -5 and -56 make -61. Is anyone uncomfortable with how we got -61? I'm more than happy to explain it. Everybody okay with it? Okay, all right, so we have -61 in, we've combined our like terms. Now what?
Bring down the -8 equals -8.
Bring down -8, bring down equals, bring down -8. Okay, so where do we go from here?
You can add 8 on both sides.
Let's add 8 to both sides. Okay, so +8, +8. And
cancel.
it cancels on both. Wow.
Oh, yeah.
So if it cancels, it means it becomes 0. So we don't want to leave nothing on the other side. -8 + 8 = 0. We're gonna put a 0 there.
Ah.
Yeah. Yeah. So when
now
we're
we-
canceling terms, the reason we cancel them is because they add up to 0. We just don't write it because it's not necessary. The only time it is necessary to write that 0 is when there's nothing else over there. That way we have something to use. We have a value. 0 is a number. Okay.
So now you just bring down the 61 or just stay.
Yes, we're gonna bring that down. -61 in equals 0.
Divide it.
And now, one last color switch. Let's divide -61.
It's gonna be 0.
Yep, it sure is. 0 divided by anything is 0. So, n equals 0. And there we go.
Ooh, my head hurt.
I know, that was a big one. That was 1, 2, 3, 4 steps. It felt like a lot more.
Yeah.
That felt like 10 steps. But that is how we got n = 0. There it is.
It makes sense. Once you really look at
Okay,
it.
guys, we're gonna take a break. Whenever we come back, we are gonna talk a little more about these multi-step equations, and we might even talk about some where there's variables on both sides. So I am gonna say, let's see. I usually like to give you more time than I'm supposed to. Let's say we'll start back up around 2:15.
Okay.
Around 2:15. So
I'm
pauses.
gonna be in my doctor's appointment.
That's okay. All right. Back from our little break. And I wanted to run through one more problem from this worksheet that somebody mentioned to me that I think is worth mentioning. Let's look at number 16 on that worksheet. And number 16 is -2 equals negative, in parentheses, n minus 8. So this is another case where I have something weird going on. I have a negative outside of a quantity in parentheses. Now there's not a number out here. Does anybody know what we would do in this scenario?
You distribute.
Yes, you're distributing and you're basically thinking of it as a 1, a -1. So whenever you have a negative sign, all it means is you're going to distribute this negative. You can think of it as -1 if that helps you think of it in another way. So really what's happening is this is turning into -1 times n, which is -1n. Or you could say -n. However, sometimes I think it's easier to remember to get rid of that after if we include that 1 in there. So negative 1n or negative n, both are right. And then we have a negative times negative 8. What happens to negative 8?
Turn into a
It
positive.
becomes positive 8. Good. So this is what happens on this side here. Now I have negative n plus 8. And I'll bring down my equal sign and my negative 2. So now we are here. Negative 2 equals negative 1n plus 8. What would we do next?
You subtract 8 on the side.
Let's subtract 8 on each side. My 8s will cancel. And negative 2 minus 8 is
Negative 2.
negative 10. Good. Negative 10 equals negative 1n. One more step.
Divide.
Divide by negative 1. Good. And that is going to give us an answer of positive 10 n. Now, if you decided just to write negative n plus 8 instead of negative 1n, I'm going to get your question right after this, Melina. This is kind of how this part would go. You did the same step of subtracting 8 from both sides, just like we did over here. We'd get the same answer of negative 10 equals, and instead of negative 1n, I would have negative n. Now, if you recall last term, if you were here for this, we talked about if we get a negative n, we just take that negative sign and move it to the other side of the equation. We can do that. And here's how we do it. If I want to take this negative and put it over here, now I have n and negative 10. What on earth what's that? What happens when you got two minus signs beside each other? They become a positive. It's positive 10. It's like they cancel each other out. So that is two different ways to think of this problem. All you're doing is dividing by negative 1. It's changing the sign. Okay. And what was your question, Melina?
I don't understand how negative times 8 is a positive.
Okay. So that's a great question. What we have over here is negative times n minus 8. So whenever we have a quantity in parentheses, if this was n plus 8, that negative would turn our 8 into negative 8. But whenever we have a subtraction problem in parentheses, we are considering this 8 to already be negative. We're looking at the sign that is to the left of the number. And since the sign to the left is a minus sign, what's happening here is that negative is going over to that minus 8, which is essentially being thought of as negative 8. So really what's happening if I were to break it down to every little step is we have negative n, I'll bring down my minus sign, and then negative and 8 gives us minus negative 8. Negative n minus negative 8. And the negatives, when they're right beside each other like this, it becomes a plus. They cancel each other out. So a negative times a negative, if you want to think of it that way, gives us a positive. If you want to think of it in the bringing down the negative or the minus sign and then using negative 8, minus negative 8 is the same thing as plus 8. So there's two different ways to think of it. Does that help clarify? Okay, then. Good. All right. I'm going to go ahead and flip to a new page. Does anyone still need these? No. Jokey, I'm going to move on then. And the last thing I would like to talk to you guys about variables on both sides, because that can get a little tricky. So let me title my page again. is Algebra 1 and page 4 of our notes. We will title this page Solving Equations with Variables on Both Sides. What would we do if I had problems like n plus 3 equals negative 5n plus 25. Ooh, that's a big one, but we can do it. There actually is no one correct answer for what to do first here. You can do a few things, and you have a couple of options. So once you guys have that copied down, what are we thinking might be a good first step? Multiple correct answers.
You can combine your like terms first.
Yeah, we could combine our like terms first. Now, here's where we have to be careful. Before, when we were combining like terms, if they were on the same side of the equal sign, we just combine by adding or subtracting whatever it tells us to do. Now we have variables on opposite sides of the equal sign. This equal sign is separating it. And anytime I move one thing or a term from one side of the equation to the other, for example, let's say I wanted to move negative 5n, would I do minus 5n again on both sides? Or would I do plus 5n? What do we think?
Yeah,
We're going to do the opposite. We're going to add 5n because, why? Does anyone know why? Why do I need to do the opposite?
Because it needs to cancel out.
Yes.
We're trying
Yes.
to remove the variable from one side and put it on the other.
Exactly. Having a variable on both sides is problematic. I need my answer to say n equals a number. I will never get there if I have n equals n and a number. That's not solved. I need n on one side. So to get rid of the n on one of the sides, we need to cancel it out. So let's get rid of the negative. I don't like negative numbers. We'll add 5n. Where else do I add 5n?
Under 6n?
Under 6n. Good.
We've got 11n plus 3 equals positive 25.
Yes. We combined, I have 11n. We'll bring everything down. Plus 3 equals, the 5's cancel, 25. Now, why am I not bringing that plus sign down with the 25?
It's just kind of not necessary.
You don't need it anymore. I'm not adding 25 to anything. I like to think of a plus sign more as an and sign. I have negative 5n and 25. Now I only have 25. I don't need that and sign anymore. Okay. So now I have an equation where all my variables are on the same side. What do I do next?
Subtract 3
Subtract 3
from both sides.
from both sides. Yes. And we know our 3's are going to cancel. So we'll bring everything down. I still have 11n over here
That equals 22.
equals perfect. 25 minus 3 is 22.
Then you divide by 11 on each side.
Yes, then we divide by 11 on both sides.
Your 11s cancel.
Yes.
Your n equals 2.
N equals 2. Very nice. So, whenever we are solving equations with variables on both sides, we need to get all the like terms on one side. And whenever I say like terms, for example, my numbers with n's are like terms. So 6n and minus 5n, these are like terms. 3 and 25 are like terms because they don't have variables. So in both cases, we're just combining like terms. I'm combining my n's, I'm combining my non-n's, and I'm putting them on separate sides. So let's see. Let me give you another one. This one's going to be really, really similar.
So it don't matter what like term goes on what side.
It doesn't matter. You could, if you wanted to, subtract 6n from both sides, and then you would just end up with negative 11n and negative 22. You'll end up with the same answer of positive 2 because the negatives will cancel. So either way works. It's really up to you. So let's get another one like that. It will be very similar. Bless you.
Thank you.
4n plus 2 equals negative 3n plus 51. Now, I mentioned earlier that there are multiple correct answers. Brian, you mentioned one of the other possibilities where we could put the n's on the other side. So we could have subtracted 6n. The other options that we could have looked at in this problem is if we didn't want to combine our n's first, you could have subtracted 3 first or subtracted 25 first. You could do so many different things to solve it. You will always get the same answer as long as you are being consistent with your signs and everything, okay? So with all of that covered, let's look at the second one here. I have 4n plus 2 equals negative 3n plus 51. What do we want to do first?
Add 3.
Add 3? The
Add
3n?
Yes.
Yeah, let's do it. Plus 3n. And where else do I add 3n?
Under 4n.
Good, under 4n. So plus 3n. All right. And what happens next?
The 3 n's cancel.
Yes, and 3n's cancel.
Then you drop everything down 7n
Perfect.
plus 2 equals 51.
Bring everything down. 7n plus 2 equals 51. All right, same process. Now we're moving on to the next step.
You subtract 2 on each side.
Perfect. Subtract 2 on both sides. And 2's cancel.
Over your 7n equals 49.
49.
Then you divide by 7.
Perfect. Divide by 7.
N equals 7.
N equals 7. Not bad. Great. Great. Yay. Okay, so there's two examples. Two examples of solving equations with variables on both sides. How do we feel about these? It's a little different, but not too crazy. Not too crazy. So now that we've done a few together, let's look at some of these crazy ones that are on this worksheet, okay? It looks like we have problems with variables on both sides for numbers 21 through 24. All 4 of those have variables on both sides. Now, before we do move on to that, does anyone have questions about the process that we went through here? That's good. All right, can I move this? Are you ladies still writing this? Oh, perfect. Take your time, no problem at all. I'll pause this while you're writing. So. One. On from there. And again, I am looking now at the back side of the worksheet I gave you. And we are going to start by looking at number 21 together. So I'm going to write number 21 out for you. But first I'm going to title my page so you have a minute. Page 1. So number 21. I have 8 times 4k minus 4 equals negative 5k minus 32. Now, at first glance, like as soon as I look at this problem, it looks terrifying to solve. This just looks like a mess. But we're going to break it down, and it's really not so bad. So, looking at this problem, what do we immediately know we need to get rid of first?
The 8.
The 8.
Gotta distribute.
Yes, we need to distribute because by getting rid of this 8, we're getting rid of the parentheses. We can't mess with anything inside the parentheses until we multiply 8 by everything in there. So we are going to start with distribution. What is 8 times 4k?
32k.
32k. Now I have 8 times negative 4.
Negative 32k.
Good. And this time there won't be a k.
Oh, I'm sorry, yeah.
That's okay. Minus 32. Okay. And what do I do next?
Bring the rest of your problem down.
Bring the rest down. Equals negative 5k minus 32. Well, and now this doesn't look as scary. Now we have a problem similar to the ones I just gave you. So we have a couple of options for what we could do next. What is one of the things I could do next?
You can add 5k on each side.
Yeah, let's do that. We could add 5k to each side. So I will switch my color just to show that this was our first step. Here's our next step. I'm going to add 5k to both sides. What happens here?
Your 5s cancel.
5s cancel.
32 plus 5 is 37k.
Okay.
And then you bring the rest of your problem down.
Yes, and I have 37k minus 32
Equals.
equals
32.
negative 32. Okay. So we got rid of the k on one side of the equation. So now all of my variables are on the same side. That is wonderful. What should I do next?
You could add 32 to 32.
Yes, let's get rid of that minus 32. We will add 32 on both sides.
Zero
And
on both sides.
They both cancel.
they both cancel. Now, remember, when something cancels, it really means that it's adding up to what? 0. Great. Now, there's nothing else on this side of the equation, so what should we write? 0. We want to make sure that there's something over here. And now we'll bring the rest down. 37k equals 0. Now, what should we do?
Divide by 37.
divide by 37. Now technically, it doesn't even matter what number's next to K. What's the answer gonna be? 0. It doesn't matter how large the number is. If you divide 0 by anything, it's always gonna be 0. So we get an answer of K equals 0. Here we go. Always looks scary at first go, but if we go slow, do one thing at a time, it's not so bad. Really not. But before I do go on, I don't want to assume that everybody is feeling the same way. Are we okay? Does this make sense? Is anyone lost in any way? You guys are great. This is like the fastest I've been able to move on in Algebra 1 so far. Because this is, I think it's my 3rd term getting to teach Algebra 1. And I feel like we don't normally get to this stuff until like the 2nd week. So you guys are great.
That's great. I'm telling you, pre-algebra that I took with Dave, I feel so much more
I
prepared.
bet. I bet. He's awesome.
He did a fantastic
Right.
job, I thought, yeah.
Okay, so anybody have questions about this one, or can we try one more? Let's do another. Okay, I'm gonna look at number 22 now. And, just let me know if you need me to move my paper back down. I'm happy to do that. But now we're gonna look at number 22 on that worksheet. And 22, we have -8 times -8x minus 6 equals -6x minus 22. This is really similar to the one we did above. Almost identical. Just ever so slightly different. There's a few negatives on this one that we didn't have in the previous. So I'm going to go ahead and slide this up. And let's talk about what we need to do first.
Multiply the -8 times the -8x.
Perfect. We have parentheses. We got to get rid of it. So we're going to distribute, which means we're going to multiply. -8 times -8x is
64.
64. What? Yes, 64x. And why is this positive? Good. 2 negatives make a positive when we multiply. Now, what am I multiplying next?
-6.
Yes, -8 times -6, which is
48.
So, plus 48 or minus 48?
Plus 48.
Plus 48. Good. We have another negative times a negative. Those cancel out, and they're positive. So, now we'll just bring everything down. Equals -6x minus 22. All right. So we got rid of the parentheses, we distributed, we brought everything down. Where should we go next?
I added 6x.
Absolutely. So we have a -6x. You said you're going to add 6x. And where else did you add 6x?
To 64x.
Perfect. Plus 6x. Amazing. Okay. I know my -6x plus 6x will cancel.
70x.
Yeah, 64x plus 6x is 70x. And we'll bring everything down. Plus 48 equals -22. So now we have 70x plus 48 equals negative 22. What do we do from here?
And subtract 48.
Yes, we're gonna subtract 48 now. So let's do that. Minus 48 on both sides. Now be careful when you subtract a negative from a negative. What happens when I do negative 22 minus 48?
Negative 7.
You're really adding, you're getting a bigger negative. So it's going to be negative, what did you say, Jessica?
70.
Negative 70 equals, just cancel, and we get 70x equals negative 70. Now we just have one more step.
Divide 70.
Good. So now I'm going to take, divide by 70.
That's equal to -1.
Yes, and we'll get x equals negative 1. And that is our answer. Oh, amazing, you guys. So good. Okay. Do you guys feel confident enough for me to give you an exit ticket and be done for the day? Okay, I'm going to give you one. And it is going to have variables on both sides. So, you have lots of time to finish this. We don't technically get out till 3:30. If you finish early, I highly encourage you turn it in early so that you have more time to make corrections if you need to. And here's what I'm gonna do. I'm gonna write out your exit ticket. You are welcome to write it yourself on a paper, or if you want to wait, I'm gonna make copies for the people that aren't here. I'm happy to make you guys copies as well. So I am gonna move this out of the way. Does anyone still need this?
And that'd be part of the exit ticket, just right there.
Yeah, I gotta give you one that I haven't done for you yet. Let's see. Algebra 1, and this is our day 2 exit ticket. Our day 1 exit ticket was just to turn in the math classroom agreement, the signature page. So if you did that, great, you're all set. If you don't know what I'm talking about, come and talk to me and I'm happy to help you. I'll get you a copy of that. If you are writing this on your own paper, first of all, there's only going to be one problem today for your exit ticket. If you are writing it yourself, please write that it is the day to exit ticket. That way it does not get mixed up with other days. And this is due on Friday. March 28th.
Lord.
I know, it's like going so fast.
Yeah, that's wild.
I feel like it was just January. And now it's got to be April. Pretty crazy. Okay, so for this exit ticket, you are going to solve the equation below. And that works. And it's just one question. I would like you to solve 8x plus 11 equals 4x plus 14. If you finish, you are free to go. You're also more than welcome to have me check your work before you go. So I'm going to end the recording there, and that is all for today.